Okay, so what I'm going to do is we're going to have a look at, let's have a look at the proposition, okay, the propositional expression, and the propositional expression that we're interested in is P ANDed with, let's say P ANDed with P implies Q, okay, implies, let's say we have something like P ANDed with P implies Q implies, let's say we have Q, okay. Actually, let me rewrite that because I've been using uppercase letters, so let me rewrite it, okay, as the propositional expression that we're interested in is P ANDed with P implies Q implies Q, okay. Now, let's just keep in mind that this AND is tightly bound to this particular structure here. So actually this propositional connective here, this implication, its premise is this over here, and its conclusion is this thing here. Okay. So what we'll do is we'll evaluate the left hand side first, and then we'll evaluate the right hand side. So the propositions that are fed into this particular statement here are P's and Q's. So our truth table is going to just consist of P's and Q's. So we have P's and Q's as our inputs. They could be false, 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 true, true, false, true, true. Okay? And what we'll do is we'll evaluate the premise first. Okay. So the premise says that we to take the P column, if it's evaluated, it is. There's the P. All the truth values are listed down here. We need to AND them with the truth values for this expression here. But we haven't evaluated this expression. We don't have a column in our table called P implies Q. So what we need to do is we need to build one. Okay, so what we're going to do is we're going to build a column P implies Q, which is just the definition of the implication. And let's keep in mind the way the implication works. Okay, the implication only ever gives us false when the premise is true and the conclusion is false. So this is just the definition of the implication. So this here is false here. Everywhere else it's true. Okay, so now for this AND we have the left hand part listed here and we have the right hand part listed here. So now we can do the AND. We can do P ANDed with P implies Q. Okay, where this is the premise and this is the conclusion. Sorry, I'm telling lies here. No, where this is the left operand, the P, and the right operand is the P implies Q. Now we know the way an AND works. Excuse me. An AND only ever gives us true when both of them are simultaneously true. So for this AND here, we're looking down the P column, which is here, and we're looking down the P implies Q column, which is here, for two true values. And you can see that the only place we have two true values is at the very end here. So this is true. Everywhere else it's false. Okay? So we've just evaluated the premise for this particular implication. And then what we need to do is we need to build the implication. We've already evaluated the Q. Actually, what I'm going to do is I'm just going to put the Q column down here again because it's probably a little bit more logical in relation to the ordering. Yeah? Okay? So the Q's in this case are false, true, false, true. And you see I've rewritten them as they are listed here in the Q column. So now consider this to be the premise for this implication and this to be the conclusion. And we know the way an implication works. So what we're going to do here is we're going to define P ANDed with P implies Q implies Q, where the premise is this thing here and the conclusion is this thing here. Okay, so we know the way an implication works. An implication is only ever false when the premise is true and the conclusion is false. So in this particular case, we're looking for a true false. True, false, no. Any true falses? No. There's a true, but it's a true here. So we've never got a pairing of trues and falses. We never have that type of pairing. So what we know is that this implication here is never false. It's always true. And here is an example of a tautology. Tautology. Okay? Because all of the outputs, yeah, under all conditions, all inputs, all states, yeah, that the proposition could be in, which are dependent on the P's and Q truth values, under all possible pairings, all possible states, the output is always true. And that's an example of a tautology. Okay? And I suppose we could move on and we could do something a little bit more complicated where we have an example of a let's say where we have an example of something like a contradiction and so on. Yeah, but I think this sort of covers it for us at this stage in relation to what is a tautology, what's a contradiction, and what's a contingency. A tautology is simply a propositional expression that, when fully evaluated, okay, always gives you true values. Okay, that's a tautology, and we had a nice example of a tautology here. Okay, sorry, that was in the previous video. We had a nice example of a tautology, which was done here. Okay, for this video. Okay, an example of a contradiction. There's a propositional expression here. When it's fully evaluated, you can see we've always got falses, they're contradictions. And we had loads of examples of contingencies, yeah, okay, from our connectives that we defined at the start of this particular series of videos on propositional logic. Anytime we've got mixtures of falses and trues on the outputs, well, then they're called contingencies. Okay guys, once again, my name is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope this video was in some way intuitive, and more importantly I hope that was actually helpful for you, and thanks for watching.